NASA gave a major announcement. Pluto isn't what you think. What is NASA proposing here? Are they interpreting the most recent exposures from the New Horizons space mission, which shows that odd things are happening on Pluto's surface? One of the striking images clearly shows something that seems to float across the external layer of Pluto. This raises unsettling questions about whether some sort of high-level dark life exists on this distant world, or if we are dealing with a well-understood geological feature. Pluto might be small, but the stories it holds are vast and filled with surprises. When Pluto's planetary status was revoked in 2006, scientists were unaware of the information from the New Horizons mission, which had just reached Pluto after years of travel. Since then, we have learned there is much more to this small object than expected. How did astronomers decide to demote this planet, which many of us grew up learning about? After discovering several other small planets in the Kuiper belt, they realized a definition was needed for what constitutes a planet versus a dwarf planet or a trans-Neptunian object. Pluto scored points for its size and round shape, but the planet shares its orbit with several other objects. The orbit was therefore considered unsuitable, and this became the justification for why Pluto was not categorized with the other massive planets in the solar system. Many people on Earth think this decision was unfair. NASA and other space agencies received letters of protest from prominent scientists and the general public, urging them to reconsider Pluto's status. Some state-run organizations even got petitions from residents requesting that Pluto be classified as a planet again. Pluto's planetary status had been recognized since the 1930s, making its demotion a difficult adjustment. In 2015, when New Horizons sent back the first real image of Pluto, the world saw its charming face for the first time. Imagine seeing a true picture of Pluto after only seeing artistic representations in textbooks. Even the most detailed images from the Hubble telescope couldn't compare to the stunning close-up sent by New Horizons. The small planet appeared beautifully structured and even had a heart-shaped feature. Since then, Pluto has gained even more fans, and perhaps one day, space experts will reconsider their stance. The first confirmed images of Pluto took everyone's breath away. It was a treasured moment when the first data from New Horizons arrived at Mission Control in 2015. Everyone present knew they were about to see a planet they were familiar with but had never truly seen up close. What the mission revealed about Pluto completely changed our understanding of this distant world. Pluto turned out to be far more dynamic, complex, and alive than planetary scientists had previously imagined. Its surface displayed stunning features that no one had expected. With each new image, Pluto transformed from a distant, icy world into something significant and surprisingly active. Its landscape revealed giant blocks of ice, deep crevices, and smooth, icy plains. It even showed geological features that suggested internal heat sources. One of the most astonishing discoveries was a massive block of ice that appeared to be floating across the planet's surface. This block, made of nitrogen ice, revealed that there might be a supply of nitrogen deep beneath Pluto's surface. Geological activity could be pushing these blocks upward, forming strange, mountainous shapes. This suggested the possibility of a warm interior, hinting at potential subsurface oceans or reservoirs of liquid water. The idea of internal heat changed how scientists viewed Pluto. It suggested that, despite its small size and distant location, Pluto might be more geologically active than previously thought. The heart-shaped region known as Sputnik Planitia became one of Pluto's most iconic features. This vast ice plain, composed mainly of nitrogen ice with traces of methane and carbon monoxide, stood out due to its bright, reflective surface. It was likely formed by a giant impact and later modified by internal processes. Sputnik Planitia's flat, smooth surface suggests continuous renewal through convection processes within its icy layers. Researchers even speculated that a liquid ocean might exist beneath the ice, kept warm by Pluto's internal heat. Pluto's environment is more dynamic than once imagined, with seasonal changes driven by its distant orbit around the Sun. Its thin atmosphere, composed of nitrogen, methane, and carbon monoxide, expands and contracts as Pluto moves closer to or farther from the Sun. One of the most surprising findings was that it can't snow on Pluto, though its snow is made of frozen nitrogen and methane, unlike Earth's water-based snow. These snowfalls reshape Pluto's surface, contributing to its evolving landscape. The stunning geological features and mysterious processes on Pluto continue to fascinate scientists. With every new discovery, Pluto proves itself far more complex and intriguing than anyone could have predicted. The possibility of internal heat on Pluto suggests that it could have cryovolcanic activity, where icy materials like water, ammonia, and methane are pushed to the surface due to subsurface heating. This type of volcanism differs significantly from Earth's molten rock volcanoes, but is just as fascinating in the context of outer solar system bodies. One of the most intriguing regions on Pluto is its heart-shaped feature, Sputnik Planitia. Researchers believe that the nitrogen ice here is slowly moving and reshaping the landscape through a process similar to convection cells in Earth's mantle. This activity points to a surprisingly dynamic world. Additionally, Pluto's geological diversity includes towering ice mountains made of water ice, which remain solid due to the planet's frigid temperatures. Some of these mountains are as tall as the Rocky Mountains on Earth. The contrasting terrains, icy plains, rugged mountains, and mysterious dark regions indicate a planet with a rich and active geological history. Pluto's thin atmosphere also behaves in unexpected ways. As the planet moves closer to the Sun, its atmosphere thickens as nitrogen and methane sublimate, change directly from solid to gas. When Pluto drifts farther away, the atmosphere refreezes onto its surface. This seasonal cycle affects not only Pluto's weather but also its surface features. The discovery of potential liquid water beneath Pluto's surface has raised questions about the possibility of life. While Pluto is incredibly cold, the presence of heat from radioactive decay and internal friction might sustain pockets of liquid water, providing a potential habitat for microbial life. The New Horizons mission has fundamentally changed how scientists view Pluto. What was once considered a cold, dead rock at the edge of the solar system is now recognized as a complex, dynamic world full of surprises. With its shifting surface, seasonal atmosphere, and possible internal ocean, Pluto continues to captivate scientists and space enthusiasts alike. Though Pluto's planetary status remains a subject of debate, its scientific importance is undeniable. The discoveries made by New Horizons have reshaped our understanding of the Kuiper Belt and the outer solar system. Pluto may be classified as a dwarf planet, but in terms of its mysteries and scientific intrigue, it stands among the giants. The exploration of Pluto reminds us that the universe is far more complex and wondrous than we can imagine. As scientists continue to analyze the data from New Horizons and plan future missions to the outer solar system, Pluto's story is far from over. Its icy heart still holds secrets waiting to be uncovered, promising new revelations about the nature of planets, moons, and the building blocks of life in the cosmos. The potential for future missions to Pluto is an exciting prospect for astronomers and space enthusiasts. While the New Horizons mission provided groundbreaking data, many questions remain unanswered. A follow-up mission equipped with advanced instruments could explore Pluto's interior, its potential ocean, and its intriguing surface features in greater detail. One proposed mission concept involves sending an orbiter to study Pluto over an extended period. This would allow scientists to monitor seasonal changes, map the entire surface in high resolution, and even deploy landers or probes to explore specific regions such as Sputnik Planitia or the towering ice mountains. A lander mission could analyze the composition of Pluto's icy plains, study its mysterious dark spots, and investigate the possibility of cryovolcanic activity. If liquid water exists beneath its surface, a probe could attempt to drill through the ice, much like proposed missions to Jupiter's moon Europa or Saturn's moon Enceladus. Pluto's moons, especially Charon, also deserve further exploration. Charon, the largest of Pluto's 5 known moons, is nearly half the size of Pluto itself. The unique gravitational relationship between Pluto and Charon, where they orbit a common center of mass outside of Pluto, makes them the only known binary planet system in the solar system. Charon has its own set of fascinating geological features, including vast canyons, mysterious polar regions, and signs of past geological activity. Understanding the connection between Pluto and Charon could provide insight into the formation of binary systems and the dynamics of planetary bodies in the Kuiper Belt. The potential for life remains one of the most intriguing possibilities. While the surface of Pluto is far too cold for life as we know it, the prospect of a subsurface ocean raises hopes for extremophiles, organisms that can survive in harsh environments. On Earth, life has been found in some of the most inhospitable places, such as deep-sea hydrothermal vents and subglacial lakes in Antarctica, suggesting that life could potentially exist on distant icy worlds. The study of Pluto and its moons also has broader implications for understanding the Kuiper Belt. This region, extending beyond Neptune, contains countless icy objects, comets, and dwarf planets that hold clues about the formation of the solar system. Exploring Pluto and similar bodies could reveal how planets formed and evolved billions of years ago. In the years since New Horizons' historic flyby, scientists have continued to be amazed by the data returned from the spacecraft. Pluto has become a symbol of exploration and discovery, a reminder that even in the farthest reaches of the solar system, there are worlds full of mystery and wonder. As humanity looks beyond Pluto to the outer edges of the solar system and beyond, its story serves as a powerful inspiration. The exploration of Pluto has shown us that no matter how distant or small a world may seem, it can still hold secrets that challenge our understanding of the universe and our place within it. The journey of Pluto, from a beloved ninth planet to a mysterious dwarf planet and back into the spotlight, demonstrates that the pursuit of knowledge never truly ends. With future missions on the horizon and countless questions left to explore, Pluto's legacy will continue to inspire generations of scientists, explorers, and dreamers.